Cool. Hi everyone. I'm like super stoked to be talking today. I want to start by thanking Garrett and Philip for the opportunity to be here. Uh, Garrett and I overlapped that segment a long time ago, and then recently he introduced me to Philip, and this is why I'm here. So I'm tuning in from San Francisco. So I'll do a little intro about me. I'm originally from France. I moved to San Francisco in 2011. I've been using Go for almost 10 years now. I recently started contributing to the Go project. So if you've followed things that happened around WebAssembly, I worked on the WASI Preview 1 port that was released in Go 121. I also authored and maintained a couple of open source packages. Some of the popular ones that you might have used, like KCUID, KafkaGo, ParkGo. We're always, welcoming contributions. I don't maintain some of those anymore, but like I'm part of the team that maintains ParkGo still. Feel free to jump in. We're on Slack. You can find me on the Gopher Slack, on Twitter, LinkedIn, or just over email. About things that I've done in my career, I've been in the Bay Area pretty much the whole time. Worked at companies, small and large, kind of oscillating between startups and bigger companies. Always in backend roles, doing distributed systems of all sorts. Very focused on performance whenever I can. It's kind of like my geek side, I'm gonna say. And last year, I co-founded a company. And so before we jump into this topic, I want to talk a little bit about what we do. So at Stealth Rocket, we help software engineers like you and I build reliable distributed systems. So we offer a platform and SDK that injects fair scheduling, retries, and durability transparently into your applications. And if you want to learn more about how we do it, I recommend you check out this open source project that we released last year at GopherCon in San Diego. It's called Coroutine, and it includes a source-to-source Go compiler that turns your program into a resumable state machine. So if you're curious, let's check it out. Send us feedback or just let us know how we can help. So you already covered this a little bit, Philip, but I think it's the big announcement of the week. I actually prepared this talk before Go 122 was released, and I had to adjust a couple of things because now things are not unsure anymore. Like we have the release, go download it. It's really a major update when it comes to performance features. We're really getting a lot of goodies in this version. And what I want to talk about is especially the range keyword and how it has evolved in the latest version. So I know sometimes we have friends joining from other language communities, so I'll do a very quick recap of what the range keyword does. I'll show a lot of code examples to illustrate what we talk about. And I'll cover kind of three main features, which are how the semantic of range loops have changed, and the new ability to range over integer values, and some gotchas as well there. And finally, and this is my personal favorite, will be most of the talk, is the range func experiment that is not enabled by default, but is available in Go 122. And by the way, if you want to jump in the chat or any questions, feel free to. I'll try to follow along and include the comments in the presentation. So in Go, we use the range keyword to loop over a sequence of values. And there are two forms that we can use. One with a single iteration variable, and the other with two iteration variables. And so, for example, with slices, we can range over a slice with a single variable, and we get the indices of the items. But we can also do it with two variables, and we get the pair of indices and the associated values. Similarly with maps, but instead of the index, we get the keys in the map. And here we're starting to see a little bit how range is a little special because maps don't have an order. So we're getting the keys in pretty much like whatever order that the runtime has decided to expose them. We can use range also to iterate over strings. This is getting even more specialized because we can see that as we get to the last two characters, the indices here don't increment monotonically anymore. So what's happening here is Go strings are UTF-8 encoded. And in UTF-8, some code points are longer than a single byte. And what we get as the indexes are actually the byte offsets of the characters. So because the last two characters are more than a single byte, there's a longer delta between them. So basically at byte offset 7, we have one character, and then at byte offset 10, we have another one. We can also arrange over channels. So Go has great support for concurrency, and built into the language is the ability to loop over the values that are sent to a channel until that channel is closed. So this makes for very expressive syntax to construct concurrent programs, right? But also over all these four examples, we see how the range keyword is already very powerful in Go. It's very essential. It allows us to combine expressiveness with also very powerful features. Let's get to how things have changed in Go 122. So it's very auspicious that the release happened just 2 days ago, because now everything that we talk about is very hot topic. But especially because like now in Go 122, it's getting even better than what we had before. So the first difference, or the first feature or change that I want to talk about is how we're now getting a different variable for each loop iteration. So take this program as an example. In Go 121, the loop variable was shared by all iteration of the loop. This meant that the value could have changed between the time a closure was created in the loop and the time that it was read by that closure. If we add goroutines, we basically have undefined behavior because the goroutine would be racing with the loop on writing and reading the value of that variable. And we don't like undefined behaviors in Go. We want our programs to be predictable and reliable. Personally, I got bitten by this way more than once. I'm sure many of you have as well. So thankfully, in Go 122, all this pain is gone. Each loop iteration gets a different variable. So if we create a closure in the body of the loop, each instance of that closure would see a different value, which was the value at the time that it was created instead of the value at the time that it's read. I see there are people in the audience that empathize with this problem. And so what's like really nice is by upgrading to 122, we basically get those bug fixes entirely for free. There's no change that we need to make to our code. It just starts to do what personally I thought was intuitive, which is the closure should capture the value that it had seen when it was created. So second feature, and this one is more focused on expressiveness of the code. uh, is that now we can range over integer values. This is a very common pattern in programs. Basically, anytime we want to repeat something some number of times, we declare an integer and then we increment it up to a given value. So, and one place in particular where I have seen this used very often is when writing benchmarks. So if you've ever done a benchmark in Go, you probably wrote code like this, like the first example, where you declare a variable and you increment it up to reaching the number of iterations that the benchmark was configured to run. In Go 122, we can simply range over the number of iterations of the benchmark. So as we can see here, the second snippet is a lot more concise. However, there is a subtle difference between these two values that I think is important to be aware of. So in the classic loop form, the variables in the condition are evaluated on each iteration, which means that if the value changes, it can affect the number of iterations that the loop does. So in this example, n starts at 5, but because we divide n by 2 each time, we actually only perform 2 iterations of the loop. Whereas when ranging over an integer, the value is captured at the beginning of the loop. The number of iterations is kind of determined at the start, and it's not affected by mutation to the variable. So beside this detail, which shouldn't affect a lot of code, or at least not any sane code, my take is we should all start adopting range over integer because it makes our programs a lot more expressive. All right, now let's get into the juicy stuff. So these two features that I just mentioned are enabled by default. You can start using them right away with Go 122. But what I'm going to talk about now is the range func experiment. And like the name says, this is still an experiment. So some details might still change along the way. But it is available in 122 today, and you can start using it if you opt into the feature. So how do we enable the range func experiment? As usual in Go, this is dead simple. We just set an environment variable called Go experiment to the value range func, and now the entire Go toolchain has it available. And this is typical, and something that I personally really like about Go is how everything is always very simple to do, and this is no exception to this rule. Now I gotta say, range functions are a little tricky to get at first, and it took me a little bit of time to get accustomed to the construct. But after working with it for a few weeks, I now understand kind of how simple and powerful they are, and let me show you why. Range functions are basically a standard iterator model for Go. We get compiler support to help address many of the challenges that we as developer had when we tried to model iterator patterns in the past. Range over function works on functions with a specific signature, and this is what we see here in the example. So they are functions that receive another yield function as argument, and they're going to call that yield function to produce the values that will be sent to the loop. So this is a little bit, it looks a little bit like functional programming to me, right? Like we're using function values to create sequences out of, calling out other functions, basically. And one thing to notice here is the yield function returns a Boolean. And that Boolean indicates if the loop it completed or not. So for example, if you have a break statement in your loop, you need to inform the iterator that it has to stop. And this happens by returning false at the yield point. So it's important that it's important to check that return value, but it's also extremely useful to have that information because it means that we can perform, you know, we can run some code knowing that the loop has ended. I'll get into this a little bit more later on. But basically, apart from the semantics of the range function, everything works exactly the same, exactly as it would. We have two forms, one with one iteration variable, one with with two, and the body of the loop. I mean, to the for range, it looks just like it would look if you were iterating over a string or a map. And so something that is interesting to see here is how the form with two loop variables can be used to convey or to report errors when we're iterating over something. So think about the use cases for iterators, right? You're probably going to be streaming something over the network or off a file or off some location that basically you didn't want to load everything in memory. You just wanted to consume the values as they showed up or as they were presented to your application. Oftentimes, you might get a timeout or you might get any sort of errors that prevent you from finishing the sequence. And so you need to be able to report those errors. And so the two variable form here allows us to express this in a way that is very common to Go developers, right? Where we're used to handling errors by checking if the second value that is of type error is nil or isn't. And I talked about this being a standard iterator model for Go, and I want to emphasize on why it is really important to have that feature. Because having a standard means that we can create a lot more interoperability between Go packages, right? Instead of having a slightly different iterator model that you need to write adapters to kind of like plug into an algorithm that was designed to like use something slightly different. Now we can converge all the code on a single form, a single feature, and have components that are immediately composable. So I want to use this as an example to kind of illustrate what I'm talking about here. Before, and here I'm showing how to read rows off a table using the database SQL package. So we have a sort of iterative type that is the SQL.rows type, and we get it back when we do a query on a database. But look at all the ceremony that we have to do just to get the values back into our application, right? So we need to check the errors coming back from a query. We need to remember to close the iterator, otherwise we'll have resource leaks. We have to move the iterator forward by calling that next method. We need to extract the values from the rows. And at the end, we also need to remember to check if any errors occurred that could have been the reason why we stopped and would indicate that we didn't get the entire result set. So there's a lot that can go wrong here. And once again, personally, I've gotten this wrong like way more than once. And also I remember how, as a more junior engineer, it was really difficult to wrap my head around all the steps, all the things that I had to get right just to do the simple, what looked like a simple thing to me, that was just reading values off of a SQL table. So I learned by practicing. Like I need to like do something to learn it. And so when I got to learning about the range func experiment, I wanted to see if I could come up with like if I could use it to basically make this very common pattern a lot simpler and a lot safer. And so I put together a little package that is open source and it's available on my GitHub that I call SQL Wrench. And what SQL Wrench does is it gives you a wrench function that out of the query to a database. So personally, I'm very pleased with what I could achieve here, because a very complex and error-prone piece of code turned into a one-liner. And I'm using the two-loop variable form here so I can do error checking. But there's only one spot where we have to check for errors. It's also impossible to forget to close the rows, or it's impossible to forget to check for errors, because all of this is done automatically within the iterator. And the consumer of these values does not need to worry about it. And to me, this is really game changer, because basically we're getting a new construct that brings automatic resource management to go. Because within the wrench function, the differs that are declared will run when the loop exits. Remember, I was telling you about you have to check for the yield function returning false. Well, when it returns false, you would basically stop producing value. You return from your iterator. But any differs that you've declared will then be run, which means that you can clean up resources, you can close your connection, or anything that you need to do to make sure that the state of your program is correct can be automated, and it is guaranteed by the compiler, right? Like the compiler orchestrates the execution of those differs without involving the developer at all. So if you use languages like C++ or Rust, this is a behavior that's like really close to the automation you get with destructors. And not only here we're making the code more reusable, right, by having a standard model, but we're also making it safer. So it's not even a trade-off. We're just getting like better stuff across the board. With the wrench func experiment, we also introduced a new standard package that is named iter. And this is roughly the shape of the package. It's like 2 types and 2 functions, at least in the current form today. This might change. But basically what this package aims to solve for is giving programs the ability to have pool style iterators. So what do I mean by this? Basically, push style is when the range function pushes the values by calling yield. So it's pushing values to the loop. Whereas pull style is when the caller drives progress of the iterator by calling this next function. So you call next, you get back the next value or a boolean that tells you that it's that you're done. And you that way you can pull values out of the iterator. So a good rule of thumb that I found is that you usually don't want, or you usually don't need a pool style unless you're composing multiple iterators. So by default, you would always use a simple range function if you're writing wrappers, filters or transpose functions of any kind. You can just do it with the simple range functions. But as soon as you try to like compose 2 or more iterators, oftentimes you have to work on the order in which you're going to pull from one or the other. And so this is where the pool style becomes very useful. And as an example, a common pattern in distributed systems is merging sequences of ordered values. So think about compacting files, like multi-gigabyte files that are kind of like like rows of CSVs or JSON or whatever you want, like Parquet files. into one larger file. They're ordered, and you're going to like stream these files and then progressively compose the results. So it's been a dream of mine to be able to write this kind of once and for all, optimize it, and have it available, applicable to any like Go use case that it works with. And now that we have range functions, I think that this dream is becoming a reality. So like I said, I learned by doing a lot. And so I wanted to learn how to use this pool model. And for this, I put together this other package, which is also open source, which implements the k-way merge algorithm. So what k-way merge does, it's what I was just describing, is you have 0 or more sequences of ordered values, and you want to merge them back into a single one. So the merge function here takes any number of iterators and produces one iterator as output. And so, like, if you run it, basically you've got like different sequences, and then it gives you the numbers concatenated in the right order. And I think here we really see the power of this approach, because we can throw any sequence to this algorithm, like no matter where the values come from. They could come from a SQL table, from objects on S3, from a stream from a gRPC API, and we can compose them all and then merge them back into a single sequence. And even like compose it again, right? Like if you have more wrappers that you want to apply, this model is like, it's really powerful to have as a standard, directly supported by the language. And to tie back with the previous example, resource management is also solved here, right? Like we don't need to close anything. We don't need to worry about which iterator is done and need to like release connections or close files or whatever. All of this is internal to the implementation of the range functions. Now, there's a little bit of a gotcha here, because iter.pool is the way that it is implemented is with a new runtime primitive that is called a coroutine. So it's not something that's directly exposed in the language. It's more of an internal implementation detail. But the coroutines are kind of lightweight Go routines. So it's a lot cheaper than using Go routines by about an order of magnitude. But you still need runtime support to make the pool model work. And take as example, a range function is a concept that the compiler knows about, right? So it can inline it if it's small enough. It can, it can optimize the construction of the code, the execution of the code. But with the pool model, we're adding an abstraction layer. The compiler cannot help us anymore, and we're dependent on the performance of the runtime, which adds a little bit of overhead, right? Like the fastest code is the code that doesn't run. So when the compiler removes a bunch of things, and the code ends up being really fast. But when we have to go through the runtime internals, there's always a little bit of extra overhead. So in general, developers shouldn't have to worry about this unless you're maintaining a high performance stream processing package of some kind. And what I found is you can still mitigate this performance cost for just using typical optimization techniques. So for example, you can add internal buffering so that you amortize the cost of context switch, right? If you have a buffer that's going to load 10 items, and then when you pull the 10 items all at once, then you've divided by 10 the cost of that context switch. You're doing it 10 times less often. Or even better, you can model your API so that you have end-to-end batching. So you have, instead of passing values one by one, you'd pass, an iterator that produces a slice of values. And then on the other end, you also have an iterator that produces slices of values. And so that way, similarly, we can amortize the cost of context switch because we only do it once every n items instead of doing it for each one. So if you're interested in, this performance, I did a further analysis on the KWGO repository. So go check it out and reach out if you have any comments or feedback. So to wrap up the presentation, a quick recap on what we covered. Go 122 really improves the capabilities of the range keyword. We get bug fixes for free by having a different variable in each loop iteration. We can now range over integers to make common code constructs a lot more concise. And we can opt into the range func experiment, which brings a standard iterator model to Go. And is a lot more expressive and allows us to write much safer code and truly things that we weren't able to write before. So I made my slides available on GitHub. On my personal GitHub, you can find it on the presentations repository. And if you're interested in what we do with Stealth Rocket, don't hesitate to shoot me an email. And if there's any questions or comments, I think we can open up the floor for discussions. Philip, all yours.
Yeah, go ahead. Oh, I thought somebody else was asking a question. Have you been following much like internals discussions yet to know like how steady is what they're proposing here or likely to change, or like the initial reaction since this has been made available for early trial?
Yeah, there is most of the discussions are actually happening online, right? There are proposals on GitHub that are very active, that are being updated frequently. New issues that are open to kind of flesh out implementation details or details about the syntax that needs to be supported. From what I've seen, I think we're pretty close to what the final form is going to look like. Right now, the discussions are more around when do we allow the one form versus two form? How much flexibility does the language needs to provide? So it's in, from my perspective, it looks like it's in a polishing phase, which is amazing because it only gets better from here, right?
Mm-hmm. Can you go back to where you're showing the example of the SQL rows one iterator? I was looking at that iter package. You've got the two types and the two functions that come with it, and you talked about the push and the pull. So in this case, you're ranging over what I believe is one of the types, right? Over sequence one or sequence two type. Is that what that is?
Yes.
Okay.
Yes.
So you can range over sequence or sequence two, and then the pull, those are functions that you would call on a sequence or a sequence two if you wanted to manually grab the next thing from it instead of range over it. Okay.
Exactly. Yeah. So this sec and sec2, you see that there it is the signature of a range function, basically.
Mm-hmm. Yeah. All right. Cool. All right. Cool. Yeah. I looked at that package when we talked earlier, and I wasn't clear on the relationship, but now I see that in your examples. So thank you. Cool. Anybody else? Any questions, comments?
I do have a question slash, understanding maybe. So I was a couple of days back, I was writing something in the library and I was looking into the range kind of functionality. So I have to capture the variable by assigning it to a new variable. And the nature of the library is that's going to be used by like some other microservices, or so
Mhm.
let's say I wrote my code with like one Go 22, and like it supports that variable capture. But if the downstream system who use this library, they are still working with the older version of Go, uh,
Yes.
what?
So you can mitigate around this by setting your Go mod to 122, right? So it says that to use this module, you
Mhm.
need Go 122 at least, otherwise it will refuse to compile.
So all the microservices need to like upgrade themselves to 122.
Yep.
They want to use your package. So when you initialize your package with Go mod, it will put inside that go.mod file what version of Go it requires. And a little anecdote about I was playing around with the enhanced route support earlier today just to make sure that the example I showed worked. And so create a quick directory, go mod init, create this file, put the code in it, run it, doesn't work, doesn't work, doesn't work. Feel like I'm going crazy. Finally realized, oh, I initialized it with the system, the version of Go installed on my system, not with Go 122 that I downloaded separately for testing and running it because the package isn't available on the Ubuntu yet. So or wasn't at that time. So anyway, like yeah, that Go mod file has a bearing and is an important factor with being able to take advantage of newer code. So even though I was
Yeah.
executing the file with Go 122, it was gracefully falling back to the behaviors as defined by the go.mod, which I thought was really an interesting experience. Cool. Any other just random general Go questions, commentary? We can switch to that. In fact, let's say thanks to Achille. I'll stop the recording, and then if anybody wants to hang out and talk, we can do that too. But
Yeah.
thank you, Achille. Sure, appreciate your time.
You're welcome.
Arjun, is your
course.
question for Achille about this?
Yes, on slide
great.
number 19.
13.
No, 19. Yep. So just wanted to ask you about this yield thing. You said you're gonna
Mhm.
come. You said you're gonna come back to this.
Yes.
How is this working? If you can talk a bit more about.
So yeah, when I said I was come back to it, I was referring to the comment on how when you break out of the loop here, which there's nothing else to do in the function. So basically it returns. If there were any defer declared, it will run this defers, right?
Yeah.
So you know that the for loop that is consuming your values is exiting because yield returns false. So it's kind of like this machinery that is all orchestrated by the code generated by the compiler, right? Like we're just expressing our application with like something that makes sense to the human, but a lot of things happen underneath, especially this coordination between the range for loop and the function that it consumes value from. And so when for exits, it actually returns back into the range function and tells it, hey, I'm leaving now, so please terminate. And it turns out actually, if you call yield again, it will panic currently in the current implementation because there's nothing to yield back to anymore because the loop isn't consuming values. But you get the opportunity to do cleanups. You can close connections, you can release locks or whatever you had acquired, and all of this is automated and it happens as soon as you exit from the loop.
Okay. So in this case, what happens is first I is 0 and yield, it's going to yield of 0, right?
Yep.
And yield
Yep.
of 0 is true or false over here.
It's true. Yeah. So you see the body of the loop here, it just doesn't print. So it prints, and then it didn't exit the loop, right? We didn't break out of it. So it means we re-enter at the yield point and the value is true. So we continue here. And so next the value is 1. And so we yield 1, and we receive it in the variable v, and it gets printed here. We print 1, this second line. And same thing. And here we're going to stop because this inner loop that is in the range function is going to stop, right? So at some point, this function returns, which means there are no values will be produced anymore. And so the outer function, the outer loop that we're consuming these values exits as well.
Right. So we are exiting because for I range 5, because we have done 0 to 4 and we're done.
Yep.
Are we actually using the break over here? Are we doing that? I'm not sure.
In this particular example, we never take this branch.
Okay.
Yeah.
I'm trying to think.
It's just you have to put it. That's the rule. You have to check for yields.
Interesting. So if I were doing something like with the yield,
I'm going to show you a real world example.
great, that would be awesome.
Okay, so this was the package I was mentioning earlier. Right, so
Mind bumping your font size up on that a little bit. So
yeah, absolutely.
Thanks.
All right, so there's this scan function which kind of like takes the SQL rows and turn them into a range function. And so here you see if we get an error, like we yield and we return, which means like the sequence is done, we're going to stop the loop that was consuming this. But where it's interesting is like here. So this, like we're further into the loop, right? We're consuming rows and then extracting the values and then sending those rows, to the caller. And the caller might break out, right? It might break for any reason that it decided it was time to break out of the loop. So here we will get false back. And so we say, okay, if the loop that was consuming us stopped, then we need to stop too. So we return out of this function. The returning will run the defer, right? We have a defer here, so it will always close the rows. So this is kind of like, I think this shows like the whole workflow in a condition where it can actually happen.
Okay. Interesting. Well, yeah. So if you could go back to slide 19 once again, please, on the previous. So what this is saying is, if I could use this yield function, but at the same time, and the yield will let the outer loop know, like, hey, it's time to break. Is that correct? When I say that, is that correct?
So yield will let the outer loop know that a new value is available. To tell the outer loop that it's time to stop, you just return. If you finish whatever you were doing in the body of this function, there are no more values. You will never call yield again.
Gotcha. I see. Great. Yeah, this is really new to me, so thank you.
Yeah, I mean, it is very new. And like I was saying earlier, it took me a few tries to really wrap my head around how it works, but it is so powerful. I think it's going to be amazing if it becomes part of just how we think about designing Go applications.
Very nice. Thank you.
Actually, I don't know if you saw Ben's question in chat.
Yeah. So question in chat, is the yield keyword new? Is this like generative functions in Python? So this is actually not a keyword, right? It's just a function. It's a function value that we happen to name yield because it's meaningful. That's what it does, right? So conventionally, we call it yield. We could call it F. We could call it whatever we like. But it's just it's just a variable. It's just a variable of type func that takes an integer argument and return a boolean. And it's exactly like the generator in Python. Conceptually, that's exactly the same model. With a little variation is that because yield is a value, you can actually pass it as argument to other functions, right? So in Python, you can only yield within the scope of the generator. Whereas here, and it's exactly what I was doing here, right? Like the scan function receives a yield. And if we look a little bit up here, that yield gets passed as an argument to another function. And then, so we can yield through the call stack that way, not just from the scope of the first function. It's a little bit more powerful than what we can do with Python.
And in this case right there, line 215, you're just not checking the value of yield to see whether it returned a true or false, right? Just ignoring it.
So in this case, that's a good catch, but we're not doing anything else after this, right? We're returning either way. So it's, and like, whether yield returns true or false, it doesn't matter. We're breaking out. So the contract is that you have to stop yielding values if yield returns false. In this case, we stop yielding values no matter what. So we follow the contract.
Well, questions? Well, seems like maybe that's it. Thanks again, Achille. We sure appreciate your time and effort put into that.
My pleasure.
To wrestle with that and try to simplify it for us a little bit to save us a little wrestling. Appreciate it.
Yeah, just produce more range functions. We need to experiment with it so we get them right in 123.
Yeah, that's a good point. Good point. Cool. Yeah, definitely give that a shot. And so thank you. Appreciate everybody joining today and participating. I'll have this posted on YouTube soon, so you can watch for that. I'll also post a link to probably to a survey out through the meetup. I'll send it out to everybody who RSVP'd probably tomorrow. So you can give me some feedback and suggestions for future sessions, topics, speaker recommendations, things like that. That would be helpful. So thank you, everybody, and have a good evening.
Cheers, everyone.
Thank you very much.
Good luck.
Thank you so